think that one. Suppose say here, different types of surface films, I'll show it, and you should know how the force due to suffocation will act. This is something very important. I just wanted students to analyze. So suppose I did a surface film. Okay, there's a film. Tell me like here I'll draw an imaginary line. Tell me like how the molecules will exert force. So those molecules which are present here, I'll draw bigger one. Let's have this one. Now this everything is what? The liquid. This is really will help you a lot in numericals. Huh? So rather than in numericals, no, I just want a background. How the force due to suffocation will act. No. Okay, there's a film, surface film. So write like this. This is surface film. So now here I'm going to assume a molecules like this. On the surface only I should assume molecules. So I'm drawing an imaginary line. No, this is the layer one. This is the layer two. So what that layer one will try to do? Layer one will try to pull the layer two will try to pull layer one. Am I right? Any reason? Because if you take the two molecules, tell me what they do. Let me take this as molecule P, molecule Q. Agree this. So tell me like how the force of interaction between them. So they'll exert a force, attractive or repulsive. Attractive, no? So it will be like this. This is what FQP and this will be FPQ. What do you mean by that? Force force acting on P due to Q. It's attractive. Huh? And similarly, what happened? Force acting on Q due to P, attractive. So what these molecules are trying, they're trying to pull each other. I think in your home after this class, no, if you have your sister, brother, mother, or father, no, try to hold his hand and try to pull each other. So when you're trying to pull each other, what happened to distance between you and your family member will increase or decrease? Not pushing each other. You're trying to pull each other. So hold hand by hand like this. This is the biggest problem what we have. So you are standing here and so this is your brother, sister or anybody. Huh? No, each of you are trying to pull each other. Huh? Tell me like how the pull force on you will act. The pull force on you will act in this direction. The pull force on you will act here. Not a push force, it's an attractive force. Better shall I call the same thing. So what actually happening to molecule? The molecules are trying to pull each other. Okay, and this is the layer. This is the layer what we have. The layer is this one. Huh? Now this is also a very important condition I'm bringing. Tell me, shall I say layer one is trying to pull layer two? Layer two is trying to pull layer one. So here the force. I think I have arrow. Agree this. So at one point or at every point it will be acting. So therefore in the books open they have shown it like this. What is this arrow I should call? Any name for this arrow? No place. What is this arrow? Force exerted by pull force up. Force exerted by layer 2 on layer 1. What about this force? Force exerted by layer 1 on layer 2. Agree this? So this is what happens here. So if you see in the books, no, they have shown it like this. The same thing, they've just shown it. If this is a free surface of a liquid, this one, so they are what they have drawn one imaginary line, and they're showing the forces here. We took red color towards left. I think nothing wrong. They what happened? They didn't show all the colors, everything, no. So it'll be like this. And how do you like it? I should show many arrows. I'm showing only few. And what is PQ? PQ is imaginary line. And what is this? Surface surface area. This is a layer 1. This is a layer 2. So what is the surface tension? How you define? It is in books. It is defined the cohesive force acting per unit line per unit length of a line drawn on imaginary surface. That's what he mean to say. Sir, is this a cohesive force? As both are mutual attractive force, no? The force of attraction between two molecules is what we are showing it. I'll still many are asking questions, so it will be like this. Will I agree? Agree? No. There's a two. There's a one. I think really I brought a better diagram. So how to measure surface tension? What you should do? So what you should do? Just take a free surface, draw an imaginary line of length L, then calculate the cohesive force. The cohesive force per unit length will be the surface tension. I think there's an imaginary one, but it's going to help us a lot in numericals. So are you getting now? So the cohesive force is what? Like, is it attractive force? S. Is it a conservative force? S. And how do it like tangential to the surface? This is something very, very important. All our numericals do revolve around this one. So what is this? Cohesive and tangential to cohesive. What is this Fs? Force due to surface. It's a cohesive in a cohesive force, conservative, and acts tangential to surface. So some books they define like this. Cohesive tangential force acting per unit length is what surface. This is the actual definition. But in books open, they just said what like cohesive force per unit length. But what is the basic definition? Cohesive conservative tangential force acting per unit length. These are all the conditions for this particular thing. And it will act tangential to only. This cohesive force will act tangential. Now the film is flat. If the film is curved, where do we see curved film? Okay, let me bend, let me bring some liquid drop only. Liquid drop, how the film will be? For a liquid drop, how the film will be? Let me draw a small drop. I'm preparing for numericals so that in numericals we need not to struggle in searching how the force will be acting here. I think will not go. I need color. Okay, I'll get it. Okay, no. Plenty of numericals are based on. So what is the free surface? Where the free surface? The free surface is this one, no? Shall I put molecules like this? Now what are this? I'm just showing the molecules which are there on free surface. And what these molecules will do? They'll exert force. Tell me that they are not on horizontal line. If you take any two given molecules, they'll not be on horizontal line. So how the molecules will be like this. Huh? And the free surface is somewhere like this. And tell me like how the force should be there. Actually, they are near, no? So we should draw a tangent, no? So if I draw an imaginary line, then how the force will be? Of course, they're not an horizontal line. It'll be a curved one. So if you draw it, no, the free surface, tell me how the force should act here. Anybody able to imagine? Tangentially. It should act tangentially. So therefore, what I do is like, I just want at this particular thing. So how the force will act here? Or let me take, let me bring that molecules. No, no, I'm asking you to take out this. I'm asking you to draw a line here. Tell me like how the force should be acting. So if you cut this drop into two equal parts, you get hemisphere, lemon. If you take the lemon, you'll get that one. So here shall we go for half drop? Numericals will be very difficult unless you develop this particular visualization. Now what is this? This is half of the hemisphere. I think exactly half. There's a radius r. Now you tell me like how the force should act here. It should act tangentially here like this. You take watermelon or something. So here if you put any some small, say like a wire or stick something. So how do it'll be tangential? No? Instead of cutting at the midpoint, if you cut it here, so here, so we have cut it exactly at this point, the midpoint here. This one. Instead of this, if I cut that particular liquid drop or that lemon at this particular point. So why here this arrow should be vertical? It should be in this direction. No? This molecule will try to pull this molecule downward. This molecule will try to pull this molecule upward. Will I agree? No. If I cut this or say like this one, no? I think I am really showing very good diagrams. I cut this into two parts, and upper part and lower part when I separate. No, this is very, very, very clearly visible for everyone. Try to see this. What is this arrow? Force exerted by this molecule on this molecule. What about this arrow? Force exerted by this molecule on this molecule. I think some problem is there. Let me redraw it. Let me take two molecules, which I'm very specific about this. The two molecules, I'll show it here. Shall I give some separate color so that it'll be easy for you? What is this arrow? Let me show by. Oh. So I'm going to bring all 3D diagrams. So that's why I'm trying to cover the ideas with this one. Huh? No, I think it's quite clear. What is this force? Force exerted by this green color molecule on this blue color. And what is this green color arrow? Force exerted by the green color on the blue color. And what is this blue color arrow? Force exerted by blue color molecule on this one. This is what happens here. So if you draw a surface, no, it'll be acting. So instead of drawing the line here exactly on the diameter, if you draw it here, tell me how the force will be. Let me cut it at this particular point. Okay, this everything is a liquid. To show dotted line. Now, instead of cutting the lemon exactly at the diameter, you are going to make a chord here. You are going to cut it. So tell me how the force due to surface tension. Shall you put like this? And everywhere it will be. So this will be the surface, no? No. Tell me how the force should act. The force everywhere should act tangential. No, I think I have some limitations. I can't show the diagram better than this. You better take the lemon and take some any stick or pen, refill something. No, try to place it here. It will point. It will not point vertically here. I mean, this arrow will not be vertical. Will be tangential. No, because the force due to surface tension will act tangential. What about the remaining part? The remaining part will be of like this. It should be, I think, bigger one. We are going to get a problems of this kind. This is the radius. This is the radius. Tell me how the force will be. The force here will act like this. Getting the idea? So try to imagine like the force due to surface tension. Now, I'll put this particular point. How the force due to surface tension should act? Should act in this way, no? At this particular point, should act like this. At this particular, should act like this. Tangential. I think for free surface, you draw a tangent. There'll be the direction of the force. If the surface film is flat, okay. If the film lies in XY plane, tell me how the force will act. The force will be directed tangential to XY plane. Look at the film. Film is curved here. So like this open, you should identify the free surface. Hope everyone is able to understand the force due to surface tension. What we are talking is a liquid dropper. It's a drop, half drop. This is a part of a drop. I think, can we call this as a like some name? I don't know. Less than half drop, more than half drop. Fine. So let's go for the next conditions. Angle of contact, we'll discuss some theory on that one. Let me have a water. Meanwhile, you see it. Huh? I'll have water.
Can you scroll a bit up, sir?
Actually, if you have all this imagination, no, this chapter is very easy. I don't know students poor geometry skills, no. That's why I'm putting lot of effort here. So when you cut vegetables, when you cut lemon, watermelon, do make observation. Don't just only look at television, mobile here and there. Physical objects, geometrical objects, make observation of that.